Hello dear students, in this session we will try to learn how to derive an expression for motional EMF. Okay, what is motional EMF? Let us suppose that we will consider one uniform magnetic field. Okay, this is uniform magnetic field. Here the magnetic field lines are going into the plane of the board. So this is the direction of magnetic field into the plane of the board. So here what I have done, I have considered one conducting rod. Say I call this rod as PQ. PQ is the conducting rod. And this rod is moving with a velocity V perpendicular to the direction of magnetic field. Say the length of the rod is L. Length of the rod is L. Now here what we have done, here we have taken a conducting frame and kept like this. So this is a conducting frame. So I name this point as R, this point as S. Say at a given instant, distance between R and Q is X. Okay. Now as the rod goes perpendicular to the direction of magnetic field, a current is induced in the rod. Okay. So the direction of current induced is given by Fleming's right hand rule. What does it say? If the forefinger points the direction of magnetic field into the plane of the board and thumb represents the direction of motion of conductor. See, the rod PQ is going towards left. Then the central finger will give you the direction of current. So this will be the direction of current in the rod. Okay. Now what is the reason for that current is because if you use left hand rule, okay, if you use left hand rule, basically what is happening inside we'll see. Forefinger points the direction of magnetic field. Rod is going towards left means all the free electrons in the rod are going towards left, means direction of current is right. Correct now? Then all the electrons will experience a force upwards. In the rod, all the electrons will go up, or electrons will experience a upward force. So this end will become negative and this end will become positive, means there is a developing of EMF. Some EMF is developed. Now why we have kept this conducting frame? So if we keep the conducting frame, because of that EMF, current will flow. That current will flow. In which direction that current will flow? That can be explained by Fleming's right hand rule. Or naturally, if this is negative potential, if this is positive potential, current will go from positive to negative, like that. Okay. But what is the most important thing here is this conducting frame is not important, direction of current is not important. What is the important thing here is when a conductor moves, okay, across or perpendicular to the magnetic field, okay, then some EMF is induced in the conductor. That in EMF we call it as motional EMF. This is very important. Now, flux through this loop PQRS, okay, is given by flux is equal to, basically flux is equal to BA cos theta, correct now? Flux is equal to BA cos theta. If you look at this rectangular frame PQRS, area vector is also into the plane of the board, magnetic field is also into the plane of the board, angle between B and A is 0 degree, cos 0 is 1. So flux can be simply written as B into A. Okay. Now what is area? Area is equal to length into breadth, L into X, B into L into X. Okay. Now how to find induced EMF? Okay. Because we have to find motional EMF. Okay. So according to Faraday's law, we know that E is equal to minus d phi by dt. Minus d phi by dt. In the place of phi, you substitute this BLX. So what happens? So differentiation of BLX with respect to time. Here you see magnetic field is constant because we have considered uniform magnetic field V. Okay, that magnetic field is going into the plane of the board. Length of the rod, length of rod PQ is also constant, but this X is variable. When the rod PQ goes towards left, this X decreases. Okay, then E will be equal to minus BL into dx by dt. Here there is one important thing. Generally, dx by dt means velocity. Correct now? When the displacement is increasing, velocity will be x2 minus x1 divided by t2 minus t1. x2 will be bigger. If x is increasing, x2 will be bigger. Here what is happening? X is decreasing, means x2 will be smaller. x2 minus x1 will become minus. Therefore here in the place of dx by dt, I'll write minus v, I'll write minus v. Why minus? Because x is decreasing, that is why I'll write minus. Or induced EMF is equal to B into L into V. Very simple derivation. But here there is a special case. Okay, note, if angle between B and area vector, angle between magnetic field and area vector is not 90 degree. Say for example, now this conducting rod is going perpendicular to the direction of magnetic field. What if the rod goes like this, or what if the rod goes like this? Okay, then area vector A will make some other angle other than 90 degree with the magnetic field. Then what happens? In the place of flux, you cannot neglect this cos theta. Cos theta is not equal to 1. Then you will get BA cos theta. When you differentiate, you will get sin theta. Then induced EMF will be equal to BLV sin theta. Induced EMF will be equal to BLV when the angle between magnetic field and area vector is theta. Then the induced EMF, motional EMF, is equal to BLV sin theta. If the rod is moving perpendicular to the direction of magnetic field, then the induced EMF is BLV. Hope you understood this. Thank you very much.